As you can see that today's topic is AI lifecycle and best practices. So when I looked at like the schedule that it's my today's topic is 20 to 25 minutes, then I was thinking like, okay, what am I like? What should I like show to people that will actually help? Then I got this idea like, why don't I show like all the best practices and things that we actually miss when we work in the AI and data science domain? And a lot of things and use cases that I will use at the end are I learned them last week from my executive ed at Harvard Kennedy School. So there was like a program I was attending with a lot of like a C6 level employees in US and all over the world. So yeah, like lots of like real life best practices and how AI actually impacts our society and our like different countries. If I talk a bit about myself, my name is Rahat Yasir. I work at Data and AI Platform Architect at CAE. So we mostly design aviation, military, defense, aerospace, and also healthcare-based systems. And we are based in Montreal, Canada. And other than that, I'm also a Microsoft MVP in AI section. It's been like 6 years that I'm a Microsoft MVP. I do give like a public speaking, public talks in data science, AI all over the world, always. And it's been like 6 to 8 years that I'm doing it. Maybe have talked at like 130 or 40 plus conferences. So thank you for having me. So, as Loic shared few things, I was thinking like when I was like seeing his presentation, there are a few things that are common. The first thing is I wanted to like share a bunch of AI myths and truths. So first thing, 80% of AI applications fail. So that is the truth, unfortunately. But the real fact is why they fail. We need to know because we don't think about the complete picture. We just think about just the model. Model is not, it does not produce any kind of value. It's just a binary file. But the model that we use, we need to connect this model with client side application, mobile applications, software systems, so that all the systems that we have, they can actually use that, get empowered and leverage them. So that's what is the case. And also we like overlook a lot of like necessary steps when we do AI, because AI is a big hype, big buzz, and also everyone gets excited while designing AI. So I will also like mention those what we overlook and what we need to like focus. There is another myth we always hear: AI will take over all of our jobs. The question answer is yes and no. It depends on the job. Unskilled jobs, yes. If there is a saying, if you do something or if you teach someone to do something in 3 days, then there is an AI developer in one part of the world. In some part of the world, they can develop their AI model, and that single model can replace that human job that you teach that person to do in 3 days. So if you are into developing, creating, then you're safe. Your jobs will always be there. Then the question, another myth we hear: AI is easy. This is another thing like we heard last week that one of the professor Jim Waldo was telling from Harvard that AI is so easy these days because of those like libraries and everything, that even a dog can develop AI applications. Yes, that's true. But at the same time, whether it's a good application or bad application, that is the question. That's where you are like you will play the role. AI is easy, just downloading a paper and like just thinking, oh, this is the pre-trained model, let's just use it. Yes, but again, like there is a bad thing or sad thing that a lot of model like papers that we see in the market or in research area, they're not reproducible. We cannot like they're unproducible literally. Like we cannot produce the same theory to in a practical aspect. And also a lot of research that we see or YouTube videos that we see, they're kind of like created on an isolated environment with ideal or best practices or best use cases, best data. But in real life, when we design our AI, they're not that easy or that ideal. So we need to like keep it in our mind as well. AI will have bigger impact than the internet. That's true. So a bunch of like Silicon Valley based CEOs have said that quote because what they think that internet has connected all the devices that we have, IoT devices, softwares, mobile apps, or web application, web apps, everything. But what AI is doing, AI is kind of like empowering all of them. AI is giving them the brain. AI is giving them more knowledge, more power. So that's where AI is actually bigger than the internet, and the impact is also going to be bigger than the internet. And the another myth is hundreds of AI models behind one web application or mobile application. That is true. When we talk about AI or model, we need to know a single model produce a single number or single result. Like there is no model in the world that produces hundreds of results in the back end. No, for that kind of like network, suppose in Facebook or Microsoft, or like I was hearing an example from a one oil company, Shell Oil. So they have 96,000 models in production. So just think how many models they have trained, and most of the training pipeline is automated, obviously. Otherwise, 96,000 model training will take a lot of time by a lot of developers, data scientists, and AI engineers. So that's why hundreds of models work behind the scene in again behind Facebook, Microsoft-based applications, Google-based applications. So it's not just a single model. We need to think about a network of AI networks. So another thing I just wanted to mention, whenever I talk to give talks or like talk to like fresh grads or new grads, these days I see one trend is everyone is trying to get a like AI job. Everyone is trying to get into a data science. Just be smart on that sense, because AI is not the only role in the market. So if I just give an example, a company of 10,000 people, if there are like 7,000 other roles, 3,000 like IT roles, there is like 200 to 300 data science and AI roles. So rest of the 3,000 IT roles are software engineers, IT admin, architects, full stack developer, like a mobile app developer, those. So if you're not comfortable, if you don't have like any experience, if you don't find it exciting, like there is not like there is no reason to be sad or upset. There are like plenty of job roles, so whichever works for you, you should just jump in. So we do see a lot of like AI related buzz. It doesn't mean all the jobs has turned into AI. No, there are very tiny amount of jobs in data science and AI. You need to be careful based on your strength and your knowledge. Okay, as my main talk is about AI and data science, we hear a lot of thing as well, like positive, negative, both. These days, we also hear in the market or in the media that, oh, AI is just a buzzword. No one is able to like develop AI or using AI, or no one is making money using AI. That is not true. So that's why I put that slide. So if you look at your current life, so the moment I wake up in the morning, I use my iPhone. I use facial recognition to unlock my iPhone. So that is AI. That is a facial recognition based app. Then I check. What I do is I check. I live in Montreal, so it's very almost of the time in winter days. It's always cold. So I check my weather app. So that weather app is an AI based algorithm. It's a prediction. So that's what we are using. We do talk to I personally do talk to like Alexa in the morning. Hey Alexa, play this music, so that it changes my mood. So that is a chatbot or like natural language processing based application. We are using it. I'm always using Google like search engine. I believe everyone is using it. So that is also like information retrieval AI. Then we also have like personalized shopping, Amazon cart, or any other shopping app. They all of them, the shopping suggestions that we see, all of them are examples of AI. If you have health insurance or car insurance or any other insurance premium, right, these days, all the insurance premium are actually predicted by data science and AI models. So they are not predicted by old formulas anymore. So that is also AI. Then the robotics, we all know there are like lots of applications of robotics, and we have seen those cool videos of Boston Dynamics. So they're also like perfect examples of AI. If you live in Montreal or Quebec, Hydro-Quebec is using different kind of like AI models to identify utility demand and and they are also trying to predict what will be the projected usage of electricity for tomorrow, the day after tomorrow, and based on that, they fine tune their electricity capability. That is also AI. If you have used banking applications, sometimes you get information. Hey, is it the transaction that you made? Those kind of like alert system, they are not manual. They're also automatic. They are anomaly detection based AI. Plus, we are also familiar with the video processing based serverless system. So you can see literally your life is completely surrounded by AI. Whether you accept it or not, we are always communicating with AI, and those companies that are developing those AI, they're also making money. So it's not like those myth, oh, no one is making money with AI or it's just a hype. No, you need to do it in proper way to make money and to make it to do it right. So that is like a perfect example. Then another thing that I wanted to share is AI lifecycle. As we always talk about like model or just data processing or those lots of cool things, but what is the end-to-end lifecycle looks like in AI market? So there are like three different segments in any kind of like end-to-end machine learning pipeline. First one is preparing data. Second one is building and training model. Third one is deploying and predicting model. End-to-end life cycle. Things that I was talking about is there are three segments of AI application development life cycle. It is a bit different than software development lifecycle (SDLC). So in case of like soft SDLC these days, what we do, we are very agile with our process and with our methodology. We take the client requirements, we break them into small sprints, and then we take like a small case, build that one as an MVP, and then give it to our client so that they can start to use it. But here in the data science and AI, it's a bit different. Why? Because we cannot just like use a 10 row to create a model and then add one row add each row every day. No, that's not the approach. So there are like three different segments in end-to-end machine learning pipeline. First one is preparing data. Second one is building and training model. Third one is deploying the model. 70% of the time takes in data preparation. 15 to 20% of the time takes in building and training model, and 10 to 15% of the time are allocated usually for deployment and prediction. So what do you do? So usually it's always better to have more data than less data. So you and as much raw as possible. So from this diagram, you can see we have one data source. We can expect that it is a big data lake. So we have all the data, and the data is not just tabular data. The data could be in any format or any type. Okay, then we are doing data ingestion. Once we do the data ingestion, in this data preparation process, we have four cases, four steps. One is data wrangling, data transformation, data validation, data featureization. Now you can tell me, ask me if you're not a like AI or data science developer. So what is the difference? All of them looks like the same, but not really. So suppose you are doing a insurance model. So on that model, you have a data. So you need to need like the validation is whether this data is good or bad, whether this column of data, which is suppose date of birth, this date of birth has any missing value or not. If there is missing value, how would you handle that one? So validating those edge cases is actually data validation. Then once you have the data on your model, you cannot feed the date of birth. What you can feed is the age of that individual user. So what you're doing, you're loading the data, then you are checking the type of that column. After checking the type of that column, you found out it's a string type. Then you are doing string to date time conversion. Then you have the date type, date time based data converted column. Then you are subtracting from today's date to find out the exact age of that individual user. So these processes are data transformation, and data wrangling are also falling within that category. So while you are doing those steps of data loading, checking the type of the column, then changing the column type, like for data format, and then subtracting. All those steps are falling under data featureization, which is feature engineering. Uh, a big portion of your success of your model training depending on feature engineering, how good of a feature engineering you do. So AI is not like that smart to do all the data cleaning by itself, do everything like automatically. No, you will, as a human, you will have, you know, more about the data, you have the domain knowledge, so you will have to process the data and feed AI model a very clean, perfect processed data after those feature engineering steps. So okay, once you have the data, data is ready, it's properly featureized, then you select the algorithm. So what kind of algorithm you will select? In the market, you will see hundreds of algorithms. So any kind of like data that you like, suppose the data you have here, So we divide the data into three categories: category one data, category two data, category three data. Category one data is tabular data, which is like number data. Category two data is conversational or text data. Category three data is image processing or like video processing based data. So when you select the algorithm, you'll have to select based on those data category. Suppose it's like insurance model that we are building here, so it is falling under category one data, which is a tabular data. Okay, now on that tabular data, what are you predicting? You're predicting what will be the insurance premium discount for this user. So why? Because he's not driving that much during COVID days. He's staying home most of the time. Why would he pay the same price? So in that case, the insurance that you're discount that you're predicting is predicting a number: 10%, 5%, 15%, based on the profile of that user. So as it's predicting a number, it is a regressional model. So you can check like what are the regressional model there is in the market: XGBoost, LightGBM, any kind of like logistic regression, whatever works for you. And once you select the model, sometime there are AutoML tools where you can try with 10, 15, or hundreds of like regressional models on a brute force mechanism, so that it will automatically give you as a leaderboard which model is the best one for you. Once you select the model, you need to do a lot of like hyperparameter tuning. All the algorithms have hyperparameters, so you need to know to come up with the best like least amount of the error rate and best accuracy. You will have to come up with the best combination of those hyperparameter, and once you have it, then you will test that model on your testing data set, like whether this model is actually good or bad, and after that you will validate. So suppose if you design a model where you have data of a user who is 45 years old, like has occurred only one accident in last 10 years, and he has his insurance account with your insurance company from last 10 years. So if you give him 10% discount, and there's another user who is like 21 years old, just using your insurance from last 1 year, and occurred like three or four accidents in last 1 year, and if you give the new user 15%, then there is something wrong in your model. You will have to validate those situations and those edge cases so that your model gives the right information, not just any value. Whatever AI model that you design, this model will give you some number. That number could be 5, 10, or whatever classification that you have. But it's your responsibility whether that number it makes sense or not, or that number is a garbage or not. So once you have the model, now it's time to use that model. As I said at the beginning, AI model has zero value. It's just a binary based on your data set. But you will have to use that model and connect it with your mobile app, web app, or other application. Then this model will have some value, and you will have to deploy it, and people will be able to use it, and you will make money based on that. So how do you deploy that one? So as your model is just a binary like a trained file, so you have your like you take the model, you put it in a wrap it in a container, and then you also like put an API in front of that container, so that and then you expose that API to other applications. So your mobile app, web app, software will use that API call to use that model. So from your web application, your insurance broker will just like input the user information, how many years he's working with, and all the information. Then click yes. It will automate. It will send an API call with a JSON like request, all the values on a JSON request to the API, like to the model, and the model will take it, will process that single row data, and will send like a response, which is 10, 15, 20, something like that. So and then the like the person who is working on the laptop will get like, okay, he deserves 10% discount or 15% discount. So that is the process. We put models in production or and deployment and connect with our existing applications. Now the question is, what is monitoring and why do we need to monitor? So the model that you have trained, suppose this example of insurance. So you have trained this model, it's in production, it's working perfectly. Everyone is so happy. Now you are using this model from last 1 year. Next year, you find out that the new user who is 21 years old have this insurance account from last 1 year. This new year, like 2020, he didn't have any accident. It was flawless. You are giving 10. Like, will you give like 10% discount still? You will have to like identify based on the model, but if your old user who is with your account from last 10 years getting 20% discount, but last 1 year he had five accidents. So in that case, if you still give him the same 15% discount, that is unfair. So it shows you will like different kind of like data like skewing mechanism will give you that kind of alert. Hey, the data that you have in your production, like it looks like it is getting different, it is getting skewed, it is getting drifted from your actual training data. So it is time to revalidate the data, look into that one, and like retrain the model with the new data, so that the old person who had a 50 like 5 accident will get 10% discount instead of 15. The new user who had 10% discount will get 12% discount instead of 10 because of like driving really good last 1 year. So that is the importance of machine learning model and retraining. Like there is no model like there is no straightforward answer like just put the model and done. No, you'll have to always maintain, because that model is actually generating your revenue, your numbers and everything. If it's generating garbage, then that is an alarming situation. Okay, so that was the end-to-end, like any kind of like machine learning development lifecycle. Whether you design model for category one data, which is insurance premium classification, or category two data, which is any kind of like Alexa, Cortana, or NLP-based application, or category three data, which is image processing, object detection, like or segmentation or anything. You will have to follow these steps. It's like a universal steps. Now the question is, as we are also talking about best practices. So what are the best practices? The first thing is AI model does not produce any value until it empowers existing systems. So you will have to think as a product developer. Yes, you are a data scientist and AI developer, but you are not separate. You are a part of the end-to-end data science, like end-to-end software engineering team. You will have to think with them, and you need to be aligned with them. But few of the things we need to like keep it in our mind when we are designing AI models as a best practice. First one is the data processing steps. During the data processing steps, we load the data. Our data could be biased in case of like age, ethnicity, race, or gender. Suppose if you have a model, if you have a data and you're going to train the model, that data has 70% of the there's a gender column, and on that gender column, 70% of the data are male, 30% of the data are female. If you train a model, that model will be biased towards male. It will give bad information, wrong information, and it will be unfair. So if I just give a couple of like examples, look, few years ago, Amazon trained a model similar to that one, based on the existing employees of Amazon for HR purpose, for new hiring purpose. Right now, Amazon, I believe, has 62 or 68% of the employees are male and rest are female. So the results or recommendation that it was generating, it was biased because the data that you have fed is biased. So you will have to be careful about those cases, about age cases, like whether you are getting biased with the age group or not, whether you're getting biased with the gender group or not, whether you're getting biased with the ethnicity, color, beliefs, those things or not. So okay, another example of like bias is suppose there is a like application that is used in U.S. Judicial system called Compass. So that there are a lot of like use cases or like news coverage based on Compass, where it gives biased information based on the like color, based on the ethnicity. So it is very important when you are developing the model or training the data set. If there are age-based, gender-based data, you will have to balance them. You cannot train a model with 70% male and 30% female. You will have to have 50-50, or you will have to anonymize the data or de-identify identify the data so that the model will not be biased. So that is your responsibility actually as a data scientist or AI developer. De-identification, that is another thing. Whenever you are developing a model, there is a thing called based on the data that you use on the model, if you can identify a human, then there is something wrong. You should not. because that will also make the model biased. So if there are data in your data set that will help you to identify a human, then change the model, add different kind of like layers, or like encrypt or like anonymize that one, or do different kind of encoding, and de-identify all those like specific columns, so that your data, or there is no data bias, there is no algorithm bias, there is no model bias. Okay. Then the second thing is model training. Practice using white box model. So there are like two types of model in the market: white box model and black box model. So all the regressional model, classification model of category one data that we use, all of them are considered as white box model. Why? Because we can easily explain them. And what are the black box model? Black box model are like a CNN or deep learning based model, because yes, we can still explain them from a hypothetical point of view, or from a from general like theory point of view. But right now, we don't have that much computational power and capability to explain that kind of model. So it's always better to avoid this kind of like black box model and focus on white box model. To support that context, there is a like interesting like a quote that I heard like last week, which is, do not bring an elephant to the petting zoo. So why? So if you can do your thing by using a small linear regression, use the linear regression. There is no credit in using cool deep learning model. So when you are using those cool deep learning model, you need more resources, you need more like runtime, you need more like when you're doing like designing the production environment, it is going to be more costly, it needs to be bigger, and there are lots of like complicacy, and the model is black box, it's not explainable. So if you can use something easy, just go with that one. Model explainability is extremely important. There will be more importance on that one, because based on the model that you have designed, you are asking someone to pay extra as an insurance premium. You're changing someone's life. Or even if I give another example, so there was one use case that we heard like few years ago in US. One of the company, they took all the CVs from their HR system and used a bunch of NLP models to create a hiring recommendation model. And then they started to use that one, and they were really happy. At one point, there was one candidate. She was really good. She was disabled, like to walk around. She had issues. She was on wheelchair. So she applied to that model. She had all the qualities, even like she had more qualities to be an employee of that company. But what happened? That individual AI model, like after screening her CV, sent her like a rejection report. So she was shocked. She sent an email as a like, why, what happened? I just need some feedback. What is wrong in my application? Then the HR manager, when she looked at, she noticed that she has all the qualities. It's perfect. So what is the issue? The issue was when the model was trained, it kind of like it noticed that all the people that are working there are physically fit. They are doing sports. They are doing activities. So it was on their CV. So when the model created, it kind of like became biased based on that physical activity, or fitness or sports based activities. But this girl, she has all the qualities, but as she is unable to like move that like openly, because of like, or she's not involved like into sports actively, her application was rejected by the model. This is unfair, we cannot do that one. So if the model was like there was explainability, there were like proper like values, or like proper explanation, what are the impact factor, which values are impacting the most, or which variables are impacting the most based on each decision, then after training the model, the user or the HR manager could have taken a look and say, oh, sports is an impact factor here, we should not make it an impact factor, because not everyone does that, there could be some edge cases. So that's why model explainability is that important. And before just jumping into an algorithm, do like apply scientific rigor before selecting random algorithms. Like do your own different kind of like hypothetical testing and statistical testing, and then go into like selecting model. Because end of the day, AI, machine learning, or everything are general statistical methodologies with some computational capability, nothing less or nothing more. So you need to like keep that in your mind as well. And then the AI model, when you're designing the model as a data scientist or AI developer, you need to know this model has no value. This training has no value. This model needs to be usable, or like needs to connect with existing application, so that this model will generate some value. So treat model as a component of the end-to-end software development system. Have test cases, have benchmarking, why your model is taking this much resources. If you want to scale that one from 10 user to 1000 users, what are the things you need to do? Do resource planning, because sometime from my experience, I have seen one data scientist develop the model. I'm like, that is giving perfect result. I'm like, that's good. So how can I run that one in production? He was like, oh, it's running on my GP100 like full GPU with 1 minute of runtime. I'm like, okay, do you have like how many people are going to use it? Like 10,000 people are going to use it at a time. I'm like, do you have any idea if 10,000 people use it, and 10,000 people use and we allocate 10,000 GP100 model, which is also impossible, for 1 minute each, how much it's going to cost? The data scientist was like, oh, that's not my headache. No, it is your headache, because you can prune the model, do a lot of things so that it doesn't take that much resources. So the model needs to be like not, it cannot be that much costly. So it's your responsibility. Model monitoring, as I said, that's another thing you need to also like need to keep in your mind. The model monitoring, when you do, you need to have a snapshot of the training data, and then you take the production data or testing data, do a scheduling job to test or identify whether the new data is skewed from the training data or not. So you cannot have just production data and expect to monitor the model. No, you need to have training data and production data, connect them together through a scheduling once a week, once a month job to identify those data skew and data drift based on data model. And the last and most important question is identifying ROI, which means return on investment. So not AI is expensive. AI developers ask a lot of money. Having building an AI team is also expensive. So you need to, as a business, you need to identify what are the return on investment. If I invest $10, am I gonna make like $11 based on all the like investment that am I making? If not, then there is no point of putting it production. So unrealistic ROI is the key reason why 80% of the models are failing these days, or 80% of the AI research are failing these days. And if you can solve your problem through code, don't get into AI because like it's a fancy thing. That's true, but this is the last example. It's also expensive. It's complex. It makes your overall system way harder to use.
Could you briefly elaborate on how some of the best practices you see to manage and version the large-scale data sets, e.g., image and video, and their respective labels over time? Any particular infrastructural setup that you have seen to be most successful dealing with data at terabyte and petabyte scale?
So the thing is, that's a very good question, but at the same time, like the answer is nothing straightforward. Like I'm not a marketing person who will say, "Oh, Azure is the best, AWS is the best, Terraform is the best." No, it depends on your existing infrastructure of your company and how you guys are doing it. I believe your company has a lot of vendors, and they're always supporting you with different kind of like resources and planning. And also, it depends on your cost. So we always say about terabyte, petabyte of data and big data. So yes, it's always important to have a data lake where you can host all the data instead of like taking the data in different, like having redundancy of the data, different copies of the data, have everything in one place so that from the data lake, you can data scientists are going to connect to data, have their own data factory, do all the like data processing, use data breaks, all the like keywords based things in the world. But again, it depends how much of your budget, your current existing infrastructure, your data. So, and also one data lake, they're also expensive. Like one good infrastructure takes $20-50 million. So like you need to keep all the things in the mind. As I'm not a like AI like admin or like marketing person, so I'm not gonna mention any kind of like specific tool. It depends. Yeah.
If 80% of AI ML projects fail, what strategic advice could you give CTOs and founders on how to get value from these projects?
So one thing is like POC. instead of like focusing on something really big, just focus on a small thing. But when you are designing the POC, your developers needs to have a production mindset. So it is like a mindset that I see in the market between researchers and developers, because developers always work into a production mindset. We need to deliver in one sprint, two sprint, something like that. The researchers are like, oh, it's research, that's it. No, research needs to be in production, otherwise it's useless. So the mindset is important. Do a small POC so that you test early, fail early. If you pass it, then okay, instead of like redoing everything, if you have the mindset, proper infrastructure, proper those pipelining using, it could be like is Azure machine learning or AWS based infrastructure, GCP based, it could be Qflow, MLflow, TFX, so many tools these days, so that you won't have to redo a lot of those, all those things. Have one pipeline, automate all those like CI/CDs as much as possible. Do a small scope-based POC so that you know the value of the data. Before anything, you need to know, identify the data is valuable or not. Or if the data is garbage, there is no point of like spending that much money or doing anything. So it's like a incremental process. And also, not as a CTO, as a CTO plus as a business person, we all work with business analysts before jumping or like allocating resources. We do budget estimation. Okay, why we are spending this $10? What is the response? What is the return of this $10 will be over the years? So to sit with your business team, identify all the KPIs so that when you're like advancing, you are not like lost, or you don't spend too much, or you don't spend too less. You are on track.